Hello class, welcome to Geometry Lesson 9.3, which is all about circles in the coordinate plane. By the end of this lesson, you should be able to use the equations and graphs of circles to solve problems. So example 1, let's talk about the equation for a circle. So example 1 says derive the equation of a circle. Derive just essentially means how we come up with the equation, like where the equation came from. So what equation defines a circle in the coordinate plane? Well, there's a lot of words on the board right now, but what I want you to focus on first is, let's look at this. So we have the distance formula. You guys should be very familiar with this by this point. Basically, the equation for a circle is just like the distance formula, but instead of having this square root, we move that square root over and we just have d squared. But since we're talking about a circle, we're going to use r squared instead for radius squared. It's the distance from the center of the circle out to any point on the circle. Remember, that's our radius. It goes halfway across the circle. So we have x1 minus, we use h instead of x2 or x1, and then that whole thing squared plus y minus k squared equals r squared. And hk is the center of our circle. Okay, so hk is the center of our circle. That's why there's an h here and a k. So if you remember that it's really similar to the distance formula, you should be good with remembering it later on as well. All right, so if we look at question 1, derive the equation for the radius of a circle. So remember, our equation is this. I guess you don't need the 2. That's just a habit from writing the distance formula. So I have x minus h squared plus y minus k squared equals r squared. So what are the radius and center of the circle with this equation? So I want you to see if you can figure that out. If you need to go back to the last slide, do so. And then I will walk you through it. Good luck. All right, for this problem, hopefully you got 2, 3 for the center and a radius of 5. So remember, you just pull the numbers from the equation for the center, and then you just do the square root of the number over on the right-hand side in order to get our radius. If you have questions about that, please be sure to ask for some help. So this is just the theorem stating the equation of a circle. So if you haven't written it down yet, maybe take a screenshot of this. It has a nice visual for you as well. And let's look at example 2 where we practice writing the equation for a circle. So what is the equation for, that's the symbol for circle, A. And the way we name circles is by whatever point is in the middle. So if I had a circle and this was B, I would write it like this, circle B. So in this case, we're talking about a circle with the center A. So this is A. That's why it's called circle A. All right? So anyways, let's practice writing the equation. So I know I have x minus something squared plus y minus something squared equals my radius squared. So let's figure out where's my center. My center is at -1, 2. So I have x minus -1. That becomes x plus 1. And then I have y minus 2. So I'm done with that side of the equation. Now I just have to figure out the radius. So in order to figure out the radius, I'm going to have to do the distance formula between these 2 points. So if I switch over and I say d equals the square root of, see my x values, I have 1 minus -1 squared plus 5 minus 2 squared. So 1 plus 1 is 2. 2 squared is 4. 5 minus 2 is 3. 3 squared is 9. So then this is the square root of 13. And that is my radius. So then I need to do my radius squared. So that would be the square root of 13 squared. But the cool thing about that is this square cancels this square root. So that means I'm left with just 13. So my radius was square root of 13. My radius squared is 13. And this is my equation. Why don't you guys go ahead and try to solve this problem? Good luck. All right, for this problem, hopefully you ended up at the quantity of x plus 3 squared plus y plus 1 squared equals 10. The way you got that was you used our center of our circle, which was -3, -1. And then you did the distance formula between our 2 points and found out that that was the square root of 10. And if you square that, we are left with just 10. Okay? If you have questions about that, be sure to reach out for some help. And now let's talk about circle Q has a radius of 7 and is centered at the origin. So let's remember that the origin means 0, 0. And we want to know, does the point square root of 3, or sorry, -3 square root of 2, comma 5 lie on circle Q? So first, let's figure out our equation. We would have x minus 0 squared plus y minus 0 squared, because of the origin, equals 7 squared, which is 49. So then, if I simplify this, x minus 0 is just x squared, and then y minus 0 is just y squared, equals 49. So then, to test this, I'm going to say -3 square root of 2 squared plus 5 squared. Does that equal 49? If it does, it lies on the circle. If it does not, it does not lie on the circle. So 3 squared, -3 squared is 9. The square root of 2 squared is 2. So I have 9 times 2 there, which is 18. And then 5 squared is 25. So 18 plus 25 is 43. So that does not equal 49. So it does not lie on the circle. Okay. If you have questions about that, please be sure to reach out for some help and go ahead and try this problem on your own. Good luck. All right, for this problem, hopefully you used the center to write your equation. When you squared 3 square root of 3, you ended up at 27, and then you plugged the point in to test it, and you found out ultimately that 17 does not equal 27, so it does not lie on the circle. All right, so example 4, graphing a circle from its equation. So we have x minus 3 squared, y plus 4 squared equals 9. So basically, with the center, if I have a -3 here, that means my center is at a +3. If I have a +4 here, my center is at a -4. So then I would go over 3, down 4, and there's my center. And then I have a radius. So this is my radius squared. So 9 equals my radius squared. If I take the square root, I get 3 equals my radius. So then I personally would recommend drawing 3 units left, up, right, or down. Or I guess if you're looking at it, I just said my directions backwards. This would be your right, left. But, you know, look for your horizontal and vertical lines. And then plot your point at each of those. And then it's easier to draw a good circle that way. Okay. So I want you guys to try to graph this on your own. I recommend figure out what is your center, what's your radius, and then draw your graph. Good luck. All right, hopefully your graph looks something like that. Notice mine is not perfect. I don't expect yours to be perfect, but one thing I do want you to note about my graph is it's easy to tell what points things are at. Like, it's easy to tell this is -2, 0. It's easy to tell this is -7, 0. It's easy to tell this is -2, -5. This is -2, 5. If you ever question my ability to read your graph because maybe you're not great at drawing graphs just like me, I expect from you to write the points next to it so that way I don't question, okay? Write the values and then we will be good because that's you telling me you know where it would be on a coordinate plane. Or I will give you a graph to actually draw on, okay? The last example we have is using graphs and equations of a circle to solve problems. So we have Doppler radar detects precipitation within the 90-mile radius. You guys particularly like Doppler radar when it comes to trying to predict snow days, especially lately. So this should be something kind of interesting to you guys. So our Doppler radar gear in Grafton and Mayersville does not extend to Clear Lake or Davis. Where can a third Doppler station be placed so all towns are covered? So the way that you're going to go is we're going to look for Grafton, which is right here, and we're going to look at Mayersville, which is down here. And what we would do is we would draw circles with a radius of 90 miles. So if I look, it looks like each of these lines represents 30 miles. So I would go 3 units. So Grafton goes just like this. And I can connect those dots. And that's my circle around Grafton. The next one that I need to do is I need to look at Mayersville. And they also have a radius of 30 miles. So I would draw my 30-mile radius around Mayersville. And we want to see where can we put a third Doppler station so all of the towns could be covered. And if you look, Clear Lake and Davis are not covered. So we need to figure out how far apart are they in order to figure out where we need to put that third Doppler station. So Clear Lake is located at 120, 180, and Davis is located at 300, 300. So let's do a quick distance formula between there. So we have D equals the square root of, let's do 300 minus 120 squared plus 300 minus 180 squared. So then we have, let's see, if I'm actually just going to plug that all in right now instead of simplifying. I trust that you guys can do that by this point. So if we do that, we get approximately 216 miles apart from each other. And since they are more than, 216 is more than half of the distance, because let me start over on that train of thought. If our Doppler stations can only cover 90-mile radius, that means I would have 90 miles from Clear Lake, and I would have 90 miles from Davis. That's a total of 180 miles that I need to cover. But these towns are 216 miles apart. So my range is not going to make it. 180 miles is all the farther the Doppler station can go. And they're 216 miles apart, so that means that there is not a third Doppler station. Okay, so you're going to end up doing problems like that where you have some elimination, and you have to kind of think through logically, what we've been doing all year, to figure out if things are possible. In this case, it wasn't. Here is the last slide for you. We have the concept summary. The main takeaways that I need you to make sure you memorize include the equation for a circle, knowing where the center is, and dealing with the radius. You also need to be able to make sure you can graph a circle. And if you have questions about any of this, be sure to reach out for some help, either from me or a friend, and have a great day.